75 amps, just some of the loads, 75 amps for the other, plus 120 amps, plus 160 amps, plus 15 amps. So you end up with 420 amps of the sum of the loads. Then if you go in and do sum of the X divide times L divide, you get the 50 amps times 100 feet, plus 75 amps times 100 feet, plus 120 amps times 250 feet, plus 160 amps times 250 feet, plus 15 amps times 150 feet. So you end up with that whole thing, and you come up with a number on here, which is actually foot amps. 84,750 foot amps. Only in agricultural electrical could you come up with a set of units called foot amps. You know, never mind, I keep looking at my foot like you just divide them through. This is amps, divide that through, and you get the distance to the centroid, so to speak. If you're doing a mechanical engineering problem, we call that the centroid, so it's neither here or there on this one, so you end up with X is equal to 202 feet, 201.8, around 200 feet. Most people were in the 195 to 202 foot range, depending on how you read that chart. A couple of you were off by 100 feet, so I wondered. Yeah, I wondered how that came about. So that Y dimension is the same way, so that's no problem there. Problem 4, calculate the main service demand load and select the service ampacity. Main service, residential, let's see. Okay, let's find some room here first.
What's the big X there?
X marks the spot. Okay, so remember we had the barn on this problem before. The barn was 75 amps. The hay barn was 50 amps. The feed center was 120 amps. The residence was 160 amps, and the well was 15 amps. So I add all that stuff up, well, what do we end up with getting? How do we add that up for the main service center? It had instructions in the chapter. 100% of this, 100% of that, 75, so what was the first instruction?
Residence is 100%.
Residence is 100%. Okay, so 160 amps, 100%. Okay, what's next?
The largest.
The next largest is what?
Is 100%.
100% of my next largest, so 120 amps next. The largest is also 100%. Okay, we're good to go here. How about after that? 75% of the next one, so I've got that one taken care of, that one taken care of, so that's 75% of 75, right?
Right.
So 75% of 75, which is 56.3, I think.
Yeah, 56.5.
Yeah,
That's fine.
I rounded off. Okay, next one is 65% of the third one. So the third one is 50 amps, and 65% of that is 65% of 50. So I ended up with 32.5, and the fourth is 50% of the sum of all rest, right? And 50% of the rest is 15 amps, so 50% of 15 is 7.5. So I add all this stuff up, and I get 376.3 amps. So what do I get for my service?
376.
400. So I put in a 400 amp service if I want a little bit of overage. Actually, I have to go to the next size up. That's a requirement to go to the next size up. Now, you got to watch the well business. You want the well separate. So I have my main service pole somewhere in here. And then I have a well pump over here somewhere else. Okay, if I put that well pump just right there out in the open, I can actually have it be 15 amps. If I put the well, motor, bladder tank, everything in a little building, then I have to argue about what should be the service to that little building. 15 amps? Yeah, that's the question.
Why do they have to have light in the building or something?
Then you get an argument. What is the minimum ampacity load center for an ag building? 60 amps. Right. So hanging out by itself, I got a 15 amp disconnect for that motor. I put it in a building, oh crap. Do you really want me to do that? Yeah, it probably makes you put 60 amps in it.
You have a pump house, it doesn't necessarily have to be on an ag place, so it doesn't.
That's correct. Yeah.
So if it's at your house and not on the farm, then you don't have to have 16 amps.
That's correct. You could probably play that 6 ways to Sunday.
You can wait.
Depending on the
My
building.
house, that's the farm.
Right, if all I've got is a shed that's just a weather enclosure for that, I could say that's not a building at all, it's just a covering for my pump, and so it doesn't fall under that. But if the instant I would make a building that I put shelves in there and I had a light switch in there, then I'd start thinking, oh crap, is somebody gonna bust my chops on this? Thin line, you have to think about it, and it would do well to talk to, if you're building something brand new, talk to the code inspector. Say, what
Would
is
it bust you on that?
And you can
Yeah,
do
but-
it if you talk to them.
Plus the light bulb out.
Have your contractor talk to them, even better, yeah. Just mention the contractor. Will they bust you on that? They'll bust you on anything they can think of. One of the things I've had somewhat luck for is acting stupid, easy, you know. And just say, I'm not familiar with the building code, I think they updated the code last year. Could you show me the paragraph that relates to? I mean, it could be they're just busting your chops. Give the person a little bit of power and they take it and run with it. It could be just jerking the chain. Or it's something they'd like to see, but there's no reason for it in the code. So just ask them. I'm unfamiliar with that, could you quote me the paragraph? Another thing is get your utility to fight the battle for you, because the utility, being the provider of electricity, is a bigger dog than a building inspector. So you call the utility up and say, listen, I'm doing this, and I'm looking at a safety issue. I'm reading the code this way, and building officials reading it this way. What do you recommend as my provider? Bring them into the equation. Because they don't care. They can get in an argument with the building inspector and not worry about it. You can't. Because they'll just wait for you. Next time around, buddy, oh, it's you. I'll bring out the sharp red pencil. Right. So you kind of have to watch that. Be careful. Always be polite. All right. So where did I just put? Geez, everything vanished. So that is a question. You can play that a bunch of different ways, but be well aware of what the minimum requirement is for an ag building. Okay. Now, geez, I've been just flapping my jaws over here. Julio came in. Actually, I have to turn that back.
Dr. Porter, can I ask you a question about chapter 6?
Yeah, absolutely.
When you're doing just the general lighting
Yeah.
for demand load,
Mm-hmm.
do you do the same rules where first 3,000, 100%, or is that only?
That's for residents. This is for the whole, chapter 5 is for the whole.
Chapter 6,
Pardon?
for just chapter 6?
Chapter 6 is for all the requirements of residences.
Right,
So when you do the demand lighting there to come up with the load for the load center,
right,
it is the first 3,000 volt amps, 100%.
okay.
The 3,000 to 120,000 is,
Yeah, I wasn't sure if it was
Yeah.
only for when you combined required with that, or,
it's whatever's in the building.
okay.
Yeah.
So,
Yeah. Okay. So we've got that covered. What size entrance, okay. Then the next thing is what size entrance would you recommend? That would be question 5. And for 160 amps for the residents, what would you pick? 200 amp. How about for the feed center, which is 120 amps? 150. The barn, the second barn is 75 amps. What do you pick?
100.
100. Hay barn is 50 amps. sixty is the minimum standard for, and then the 15 amp, again, I think the lowest breaker on 240 is 30 amps. Alright, so that we picked 30 amps on that. Now, problem 6 is where we had a bit of a rub. No. Yeah, well, you know, you guys have been doing, it's the ones that don't do any homework that have the problem, it's not the ones that miss one point. I don't think that's gonna bother anybody. For the residents of 200 amps, you looked at a residence, 200 amps, and then you asked yourself, what wire do you pick? Well, how far away was the residence from the load pole? Ooh, yeah.
So this one requires a lot of math?
No,
Okay.
it requires some math. Yeah. All right. So, what is my resistance in my line? Allowable resistance, I want to have a 2% drop. That's typically what you do is a 2% or less drop. What's the service? 240 volts. So I have 0.02, which is 2% times 240 volts, divided by the distance. And I'm 100 feet away from the load pole, so twice the distance, because it's a circuit that goes there and back, is 200 feet. So that gives me 0.024 ohms. Now, that's total resistance. How about the resistance per 1,000 feet? Because that is resistance per what?